Now, how do you explain the cosine rule? So the cosine rule is giving us this: a square, having relations, okay? A square equal to b square plus c square minus 2bc cos theta. So we're not going to go into detail as to how this formula came about, but just understand that the condition for applying cosine rule is that when you have um, two sides and an included angle, you can actually find one other side. That is the condition. So in bearing, basically, this side may be the distance um, of the triangle. So let's say you have a triangle, something like this, and it has an included angle 110, and then you have two other sides given, let's say 5 here and 2 here. You can actually find here because of this included angle using cosine rule. Another thing is that you can actually find theta, or let's say they give you a triangle. Um, let me claim this. So let's say they give you a triangle. So this is another condition though. So let's say they give you a triangle with 3 sides. Let's say 2 here, 5 here, 3 here. But they don't. There's no angle. So with cosine rule, you can actually find theta only when you have 3 sides. Okay, so you can impute the values for A, B, and B and C here, but you can now find theta by making cos theta the subject of formula. So basically, it's going to look like maybe cos theta is equal to um, b square plus c square minus a square over 2bc. So that will give you cos theta. Okay, so this is basically the cosine rule. We'll be solving examples related to this. Okay, let's just do one example. Just let's say you have something like this. It's a triangle. This is 120 degrees, right? So this is y, this is x, this is z, this is 1 meter, this is 2 meters. Okay, now they want us to find what? Find xc. So xc is what they want us to find, and this is xc, this line here. So we're going to call this a. So we'll call this, well, let's say y. Small letter y, let's call this y here. So what are we going to do? Since we know that there are two sides given, remember the conditions for applying cosine rule. There are two sides given, and then there is an included angle. So with this, we can apply a cosine rule that says that, now using all the letters here, we're going to say y squared is equal to 2 squared plus 1 squared minus 2 brackets 2 times 1, because it's like 2bc from our formula, then cos theta, cos 120 degrees. Okay, now with this, now you can actually solve and get your answer. Your answer would be root 7 if you solve everything. So we're not going into detail, we're just showing you what it's like. Okay, so that would be your value for y. But is there a question like, what if you want to use sine rule here? So can you really use sine rule here? Let's just check. I've not done this before, so let's just check. So I'm just going to show you whether you can use sine rule or not. So when you can use sine rule and when you can use cosine rule, whether each of them can be used with a particular triangle. So basically, you notice that one of the conditions for finding sine rule is when you have an angle and a side. An angle and a side. So basically, you have an angle here, which is opposite to this side. Okay, and this side is not given, which is what we're looking for. We do not have an angle here, but we have this side here, which is also small x based on cosine rule. We have a side here, but we do not have an angle here, which is this is small z based on sine rule. So that means we cannot really use sine rule to find the value of y here, except we know one of these angles. If we know one of these angles here, we can actually use sine rule, because we now have two angles, then one side and just one side missing for us to be able to use sine rule. Okay, so the best is cosine rule here, because cosine rule condition is two sides given um, to find one side and an included angle. So if you have two sides given and you're looking for one side and then there's an angle in the triangle, you can use cosine rule. Okay, so I think that is the idea on cosine rule. So remember the formula. Um, this part here is more like the Pythagoras theorem formula, and this side is just the addition of um, the theta. Okay, so just understand that. Practice more exercises on cosine and sine rule, and you will understand exactly how to use it when solving bearing problems. Okay, so now we want to go into bearing problems proper.